3I Atlas is an interstellar object, a visitor from beyond our solar system. It was first detected on the 1st of July 2025 by the Atlas Survey Telescope in Chile. From the moment of discovery, astronomers realized this object didn't behave like a usual comet or asteroid bound to our system. Its orbit is hyperbolic, meaning it is just passing through. Early images from Hubble on July 21, 2025, captured a teardrop shape with a dust cocoon surrounding a faint nucleus. Subsequent observations by the James Webb Space Telescope on August 6 used its near-infrared spectrograph to map gas and dust emissions. Today, 3I Atlas is venturing deeper into the inner solar system, reaching its closest to the Sun around October 30, 2025 at approximately 1.4 astronomical units. It will never come very close to Earth. Its closest approach is about 270 million kilometers. So in principle, it poses no direct impact risk. Yet, what it does is far more intriguing, and perhaps more ominous than mere distance. As 3I Atlas traveled inward, scientists expected it to begin normal comet activity: ice sublimating, dust and gas forming a coma and tail. But what they saw instead was unexpected. From early on, 3I Atlas exhibited outgassing, but at distances where typical comets remain inert. The Swift Observatory detected hydroxyl emissions, a key signature of water breakdown, when the comet was still approximately 2.9 AU from the Sun, a distance generally too cold for water ice to sublimate strongly. That water loss rate was estimated at approximately 40 kg per second, like a cosmic fire hose. Meanwhile, JWST's observation on August 6th revealed the coma's composition is unusually CO2-rich, with water and carbon monoxide present in much lower proportions than expected. This implies either 3I Atlas formed in a different environment, exposed to more radiation, or its structure is quite exotic. Even more, polarization studies found that 3I Atlas exhibits extreme negative polarization behavior, much deeper and narrower than any known comets, with a very low inversion angle. This places it outside normal comet or asteroid classifications. In Avi Loeb's words, because it has no strong visible tail initially and its orbit is remarkably aligned with the ecliptic, it might not strictly behave like a comet. By September, new features began to emerge. The coma and dust envelope expanded. A tail started to become more visible. But the tail morphology is not simple. It shows asymmetries and possibly anti-tail or dust features pointing sunward. Observatories show 3I Atlas glowing green in some filters, hinting at molecules like CN or C2, common in comets, but in strengths uncommon for interstellar visitors. Webb's data also reinforce that CO2 remains the dominant gas in the coma, which suggests an exotic ice composition or a difference in how volatile ices were preserved in its original environment. Simultaneously, forecasts from solar weather models predicted a coronal mass ejection could intersect 3I Atlas around September 24-25, which could severely disturb its gas or dust envelope, trigger fragmentation, or cause structural stress. In fact, some articles suggest it might already have been hit by a solar explosion while rushing past Mars. As 3I Atlas plunges deeper into the inner solar system, the line between mystery and threat begins to blur. It is no longer enough to wonder what it is. We must consider what it might do. Already, the comet displays behavior that challenges our expectations. Water vapor streaming off its surface even when it's still far from the Sun. A coma dominated by carbon dioxide rather than water, and deeply negative polarization unseen in typical comets. These anomalous traits turn theoretical risks into becoming plausible ones. Imagine as it accelerates toward perihelion, structural stresses mounting. The heat, tidal forces, and internal pressure could cause fractures. Pieces might crack off, leading to unpredictable fragmentation. Dust and debris trails could spread in unexpected directions, perhaps crossing orbital paths. Moreover, volatile pockets deep inside the nucleus, pockets of exotic ices or compounds not common in solar system comets, could outgas explosively. Sudden bursts might eject gas, dust, or even shock the surface structure, shifting its shape or stability. Altogether, even though 3I Atlas poses no direct collision risk to Earth, the danger lies in its unpredictability. The most vulnerable moment is when it passes behind the Sun. Our view will be blinded, and any dramatic changes or events might escape detection entirely. In short, the more 3I Atlas surprises us now, the more critical it becomes to monitor every twist, because the next shift could be catastrophic in cosmic terms. Different voices interpret 3I Atlas differently. NASA and the mainstream view see it as a fascinating but natural interstellar comet, not a direct threat. In contrast, Avi Loeb proposes that its anomalies, its polarimetry, orbit alignment, faint tail behavior, leave open the possibility that it may be a technological artifact or even a probe. His preprint is the interstellar object 3I Atlas alien technology. Yet many other astronomers caution that these are speculative readings, and current data is consistent with a natural origin after all. In a bold move, NASA responded publicly to claims of alien spacecraft, reaffirming that 3I Atlas is being studied, but no evidence now suggests a threat. Even prominent voices like Neil deGrasse Tyson caution against rushing to alien conclusions. Now, in late October 2025, 3I Atlas continues to transform. The comet is showing increased activity, shedding water and gas at a surprising rate, despite still being far from the Sun. It will reach perihelion, approximately 1.4 AU, on October 30th. Interestingly, the mere possibility of a CME collision around September 24th, the 25th of May already have affected its structure or dust cloud. At Mars distance, spacecraft may capture data or images. Some scientists hope existing missions can be repurposed during the blind spot behind the Sun. The comet is scheduled to pass behind the Sun, which blocks observation for a period. During that time, no one may see new changes until it emerges again, possibly in December. Now, all eyes turn to the coming weeks. 3I Atlas continues its silent journey toward perihelion, its closest approach to the Sun. What happens next? No one can say for sure. Will it survive the intense heat or shatter into glowing fragments that drift through our solar system? Will its strange chemistry reveal something new? Something we've never seen before? Every telescope on Earth, from Chile to Hawaii, and every space observatory from Hubble to Webb is watching. Scientists are waiting for the moment when it re-emerges from behind the Sun to see what has changed. Until then, all we can do is wait and wonder. The story of 3I Atlas isn't over. It's only entering its most mysterious phase. Stay curious, keep your eyes on the cosmos, and subscribe to The Enigmatic for every new update about 3I Atlas, the universe, and the strange secrets still hidden in the dark.